Two of the world's leading robot dogs just made massive leaps forward, and the robotics community can't stop talking about it. Boston Dynamics' Spot stunned engineers with a brand new set of aerial behaviors powered by reinforcement learning, while Deep Robotics unveiled the Lynx M20, an industrial-grade robot dog with a clever front elbow, back knee design that adapts to just about any environment you can imagine. Welcome back, everyone. Alfie here, and today I've got two absolutely game-changing updates in the world of robotics. Boston Dynamics' Spot just did the unthinkable with a brand new set of aerial behaviors, and Deep Robotics has unveiled the Lynx M20, a bold new design built for real-world industrial power. You're watching the AI Nexus, and as always, we're here to walk you through every step of the future. Let's dive in. These aren't just small tweaks or minor upgrades. We're talking about fundamental breakthroughs that completely change how quadruped robots move, adapt, and perform in the real world. Spot is pushing the boundaries of agility and control, showing off aerial moves that look like something out of an athlete's playbook. Meanwhile, Lynx M20 takes a bold design step that redefines versatility for industrial robots, proving that quadrupeds are now capable of tackling environments that once seemed impossible for machines. Together, these two announcements signal something big. Robot dogs are moving beyond research experiments and flashy demos. They're becoming serious, practical machines with real-world applications that go far beyond novelty. Let's break down exactly what's happening here, starting with Boston Dynamics' jaw-dropping update. Spot has been around for years now, and it's arguably the most famous robot dog in the world. It's danced to music, climbed stairs, carried loads, and performed warehouse inspections with ease. But as impressive as those abilities were, everything we'd seen until now was grounded, literally. Spot was agile, but it was still a creature of the floor. That changed when Boston Dynamics revealed their latest research. Using reinforcement learning, an AI method where the robot learns behaviors through trial and error, Spot has unlocked stunning aerial capabilities. Suddenly, this ground-based quadruped is performing mid-air moves with control and precision that nobody thought possible. Spot can now leap higher than ever, stabilize itself mid-air, and land with an accuracy that looks more like an athlete or gymnast than a robot. Engineers describe it as acrobatic locomotion, and when you watch it in action, it feels almost surreal. For the first time, Spot isn't just adapting to the ground. It's mastering the air in brief, controlled bursts. This is more than just a flashy stunt. Controlled aerial motion gives Spot access to environments and scenarios that would have been impossible before. Imagine a disaster zone with gaps, rubble, or collapsed terrain. A robot that can leap, twist, and land safely can handle challenges that wheels or even traditional quadrupeds simply can't manage. What's remarkable here is that engineers didn't sit down and manually code every move. Reinforcement learning allowed Spot to teach itself how to optimize its movements for stability and control. The robot essentially experimented until it figured out physics-based strategies that even its creators wouldn't have thought of. That's the magic of RL. It produces solutions that are both creative and practical, giving robots a level of adaptability that feels almost human. Boston Dynamics has long been known for attention-grabbing videos, but this time it feels different. These aerial behaviors aren't about making people laugh or gasp at a dance routine. They're about giving Spot the ability to perform tasks that make it more useful, more reliable, and more versatile in the real world. To understand why this breakthrough matters, it helps to look at what reinforcement learning actually does. Instead of following rigid instructions, Spot is guided by a simple system of rewards and penalties. If a move brings it closer to success, say landing on its feet or maintaining balance, it gets rewarded. If it fails, it gets penalized. Over thousands of repetitions, Spot gradually learns what works best. This is the same type of machine learning that's behind some of the most advanced AI systems in the world, from game-playing bots to autonomous vehicles. In robotics, reinforcement learning is especially powerful because it allows machines to adapt in ways that can't be pre-programmed. For Spot, it means discovering leg and body movements mid-air that maximize control. Engineers might not know the exact angles or timings required for perfect landings, but Spot can figure it out through practice. The result is a robot dog performing moves that look like instinct, but are actually the product of advanced AI training. This development could ripple far beyond Spot itself. If reinforcement learning can unlock aerial dynamics for a quadruped, what could it do for humanoids, warehouse robots, or industrial arms? The idea that machines can teach themselves to handle physics better than humans, can program them, opens the door to a new generation of adaptive robots. Spot is just the beginning. While Boston Dynamics is turning heads with aerial tricks, Deep Robotics is tackling the problem of adaptability in a completely different way. Their new Lynx M20 robot dog might not be leaping mid-air, but it's bringing something just as groundbreaking: a unique front elbow, back knee design that changes how quadrupeds function. Most robot dogs follow a fairly standard leg orientation inspired by animals. Deep Robotics flipped that formula, giving the Lynx M20 a hybrid structure that combines both elbow-like and knee-like joints. The result is a robot that can crouch, climb, and stabilize itself in ways traditional designs can't. This design choice isn't just clever, it's practical. The Lynx M20 is built as an industrial-grade robot, meant for environments where ruggedness and adaptability matter most. Picture it navigating construction sites, inspecting pipelines, or traversing uneven terrain in search and rescue missions. The hybrid leg design allows it to handle obstacles and adjust its posture dynamically, giving it a level of flexibility that's hard to match. In other words, while Boston Dynamics is pushing agility to the extreme, Deep Robotics is reimagining versatility. The Lynx M20 is less about showing off and more about delivering reliable performance in environments where robots have to be tough and adaptable. What's fascinating here is that these two updates represent very different visions of what robot dogs should be. Spot's new aerial maneuvers push the limits of athleticism and AI-driven motion, making it an elite performer in scenarios where mobility is everything. Lynx M20, on the other hand, takes a design-first approach, showing how clever engineering can make robots more useful in tough industrial contexts. Both directions are essential for the future of robotics. Spot demonstrates how reinforcement learning can unlock unexpected abilities that expand what robots are capable of. Lynx M20 proves that sometimes the most important breakthroughs come from rethinking hardware design for real-world use. Together, they're painting a picture of a future where robot dogs aren't just lab experiments, but mainstream tools across industries. Both Spot and Lynx M20 highlight a key truth: robot dogs are no longer just novelties. They're becoming serious tools with limitless applications. For Spot, the aerial behaviors mean it could play a critical role in scenarios where humans can't go. Disaster response, military operations, or even planetary exploration suddenly look a lot more feasible when you have a quadruped that can leap, twist, and land with such precision. Reinforcement learning ensures it won't just repeat the same moves, it will adapt in real time to new challenges. For Lynx M20, the industrial-grade design makes it a natural fit for industries that need tough, reliable robots. Oil and gas, mining, construction, and logistics could all benefit from a quadruped that handles terrain with clever joint mechanics. Its unique body design could also inspire new generations of robots, showing that innovation doesn't always have to look flashy to be game-changing. And let's not forget the ripple effect. As companies like Boston Dynamics and Deep Robotics push these boundaries, smaller startups and research groups around the world are inspired to experiment. That accelerates the entire field of robotics, meaning we're likely to see even more radical updates in the months and years to come. Boston Dynamics' spot-performing controlled aerial maneuvers is something we never thought we'd see from a quadruped robot. And it's all thanks to reinforcement learning teaching it moves beyond human imagination. At the same time, Deep Robotics' Lynx M20 is proving that bold, practical design choices can give robots the rugged versatility needed for real-world deployment. These two announcements, happening side by side, show us that the race to perfect robot dogs isn't slowing down. It's accelerating. And while engineers may be shocked by what they're seeing today, it's clear that we're only scratching the surface of what these machines will be able to do in the years ahead. But robot dogs aren't the only machines rewriting the rules in 2025. Because while Spot and Lynx are proving how far quadrupeds have come, humanoid robots are making leaps that look even closer to science fiction. walking blindfolded, scaling up to full human size, and even hitting the retail market. Let's get into it. Humanoid robots are crossing a threshold in 2025, and the updates we're seeing right now are proof. Figure just revealed a walking demo that looks like a scene ripped from the future. Their Figure 02 humanoid robot walked blindfolded over obstacles without falling. Unitree is teasing a taller, full-size humanoid. And Agibot? They're launching dexterous robot hands at prices nobody thought possible, and even opening up retail sales. Each of these companies is pushing humanoids into territory that looks less like research and more like mainstream rollout. Figure has been a name to watch from the beginning. Ever since Brett Adcock and his team stepped into the humanoid race, they've made it clear they want to be right up there with Tesla and Boston Dynamics as one of the few companies capable of delivering a true general-purpose humanoid robot. But this new walking demo marks a serious leap forward. The clip shows Figure 2 navigating terrain without relying on any cameras. That means no visual input guiding its steps. Instead, the robot is operating entirely based on proprioception, its sense of its own body position and movement. To train this, the team used reinforcement learning and simulation, building policies that let the robot adapt to obstacles and changes in its environment without relying on sight. It's the robotic equivalent of a human walking through a pitch-black room. When you can't see, you rely on balance, muscle memory, and reflexes. Figure is teaching its robot to do the same thing, except with reactions that can outpace us. And here's why it matters. Vision systems, no matter how advanced, are vulnerable. Lighting changes, objects shift, shadows confuse sensors, environments are unpredictable by nature. If a robot depends too heavily on what it sees, it can be fragile. But a robot trained to keep walking blind? That's robustness. Adcock says some of the performance metrics are edging into superhuman territory. Think about what that means. A humanoid robot that not only matches human adaptability, but actually surpasses it in stability and response when faced with chaotic, unseen obstacles. That's a direct answer to one of the biggest concerns about humanoids. We've all wondered whether they'd trip and fall at the first unexpected obstacle. Picture a warehouse aisle where a box tumbles down, a hospital hallway where a patient suddenly crosses, or a sidewalk where the ground is uneven and slick. Humans adjust instinctively, but historically robots have struggled. If Figure 2 can remain balanced in all of those cases, it becomes a robot that can truly work in the unpredictable real world. And the implications go beyond walking. Reinforcement learning of this kind isn't limited to locomotion. The same techniques can be applied to hand use, manipulation of objects, and even multi-step tasks in environments that don't play nice. If Figure can extend blind robustness into manipulation, we aren't just looking at robots that can walk, we're looking at robots that can survive and function in chaos. That is the foundation of humanoids that can actually work alongside us. Now let's turn to Unitree. Unitree has been one of the fastest-moving and most aggressive companies in robotics. They started with quadrupeds, shook up the field, and then jumped headfirst into humanoids. The Unitree G1 humanoid stunned the industry in 2024 with a price tag of just under 100,000 yuan, or around $13,500. That single move forced everyone else to rethink how affordable humanoids could be. But now Unitree is teasing something much bigger. Literally bigger. The new silhouette they've shown hints at a full-size humanoid. We're talking about a machine standing roughly 5'10" with 31 degrees of freedom. That puts it right into human territory in both scale and dexterity. For comparison, the G1 was already impressive, but its smaller size limited how easily it could interact with spaces designed for us. A taller humanoid changes the equation. And the design is telling. The outline looks similar to their R1 style, a geometry that balances agility with function. Scaling that form up makes sense. It keeps the movements recognizable and practical, while giving the machine proportions that allow it to operate more naturally in human-built environments. The importance of full size can't be overstated. Most of the world is designed for people around human height. Door handles, shelves, machinery, tools, and workspaces are all set up for our proportions. A humanoid that matches that scale has a huge advantage. because it doesn't require major redesigns of environments to be useful. Then there's the 31 degrees of freedom. The higher the number, the more natural and nuanced the robot's motion becomes. That makes balance smoother, manipulation more flexible, and overall movement closer to the way we operate. It's not just about being tall, it's about being capable in ways that smaller or simpler robots can't achieve. The big question is pricing. Unitree shocked everyone with the G1's affordability. If they can bring that same pricing philosophy to a full-size humanoid, the industry will feel the shockwaves. Imagine a workplace-ready humanoid priced aggressively enough that small companies, not just tech giants, could deploy them. Unitree's strategy has always been about speed, affordability, and functional design. If this full-size tease becomes reality, it may become the first humanoid designed to scale across industries in a way that feels practical and realistic, not experimental. And then there's Agibot, taking a completely different approach, but one that might be the boldest of them all. Instead of focusing purely on entire humanoid robots, Agibot is attacking one of the toughest problems in robotics: dexterous hands. For decades, robotic hands with real dexterity have been rare and incredibly expensive. It's been normal to see price tags in the tens of thousands of dollars for a single hand. That has kept advanced manipulation out of reach for many labs, small companies, and independent developers. But Agibot just changed the game. Their new OmniHand 2025 line smashes the price barrier. The Agile model delivers 16 degrees of freedom, designed for interactive service roles, at under 10,000 yuan. That's about $1,300. The Pro model raises the bar further with 19 degrees of freedom and fine-grained sensing down to 1/10 of a newton. That makes it capable of precision manipulation that was previously limited to hands costing 10 or 20 times more. For the robotics community, that's a revolution. Suddenly, researchers and startups who couldn't justify paying $40,000 for a pair of robotic hands can experiment with dexterity for a fraction of the price. That means more innovation, faster prototyping, and more breakthroughs bubbling up from unexpected places. But Agibot didn't stop there. They're taking their robots directly to the consumer market. You can now find their humanoids listed for sale on JD.com and on their own retail site. That means they aren't just talking about commercialization, they're doing it. The entry point is the Lynx X2 Youth Edition, priced at 98,000 yuan. Then there's the Expedition A2 Youth Edition at 168,000 yuan. If those numbers sound familiar, it's because they sit right alongside Unitree's pricing for the G1 and the G1 EDU. Agibot is positioning itself as a direct competitor, price for price, product for product. This move is bold because it bypasses the traditional path of robotics companies selling only to enterprises, research institutions, or through tightly controlled channels. Agibot is saying, here's a robot, here's the price, click to order. That is the kind of step that turns humanoids from specialized research tools into products that anyone, from small businesses to schools to private enthusiasts, can consider owning. It isn't just commercialization, it's democratization. And it sets the stage for a future where humanoids are bought the same way we buy consumer electronics. Looking ahead, each of these companies faces a clear next step. For Figure, the challenge is expanding blind robustness into full multimodal adaptability. Walking without vision is impressive, but combining that with camera-based planning and manipulation would create robots that can both handle chaos and complete long, complex tasks. That's the path from walking to working. For Unitree, everything hinges on pricing and deployment. If they can bring their full-size humanoid to market with the same affordability they've shown before, they'll establish themselves as a leader in practical humanoids. A 5'10" humanoid with 31 degrees of freedom at an accessible price could easily become the most attractive workplace-ready platform in the world. For Agibot, adoption is the big test. Listing robots on JD.com is bold, but will buyers step up? If they do, we could see humanoids spreading into small businesses, schools, and even private homes. That would create a feedback loop where real-world use drives rapid iteration, making the robots even better in short order. Humanoid robots in 2025 are no longer just science fiction. They're becoming part of the real economy. A robot that can walk blind without falling isn't fragile. A humanoid that stands at human height with natural dexterity isn't a toy. A robotic hand priced at a little over $1,000 isn't exclusive anymore. And a humanoid listed on a retail site isn't a prototype for labs, it's a product. Together, these updates show us how quickly humanoids are moving from dream to reality. They're starting to look, move, and integrate like us. And for the first time, they're being offered at prices and through channels that make them accessible.